In a human cell, proteins are getting ready for a field day at school.
Hi everyone, I'm the one in the middle and my name is Myosin. Compared to all my classmates, I'm the smallest and that makes me always the last pick during gym class. Soon we're having a school field day. As usual, I was the last pick again. For field day, I'm going to be on team 2, which is full of my athletic classmates that are way bigger than me. I'm so nervous and I want to prove that small proteins are important too. I really don't want to disappoint the rest of my team.
For the first event, tug of war, Team 2 tries their hardest, but Team 1 wins in the end. With each event, Myosin falls a bit short, causing their team to be in second place throughout field day. Myosin is determined to do their best with the next activities. Myosin feels defeated. They can tell that the team is getting frustrated with them for their little contribution in the game. Approaching the end of field day, it looks like there's a tie between Team 1 and Team 2. To settle this, both teams will participate in an SDS-PAGE race. To make it interesting, the opposing teams must pick their opponent.
Please don't pick me. I don't want to be the reason my team gets second place. I'm not even sure how fast I can run.
Of course, Team 1 wants Myosin to run the race.
I really need to win this race, but how does a protein move through SDS-PAGE? In Chapter 20 of the Essential University Physics textbook, we learned about electric fields and Coulomb's law. There are two types of electric charges, positive and negative. In SDS-PAGE, proteins are coated in a negative charge while the apparatus has a positive anode and a negative cathode on either end of a polyacrylamide gel. Like charges repel and opposite charges attract. Therefore, the protein will be attracted to the anode and repelled by the cathode. This attraction and repulsion imply a force, which can be described by Coulomb's law, where K is Coulomb's constant, Q1 is the negatively charged protein, Q2 is the anode, R is the distance between the two charges, and R hat is the unit vector that points away from the protein. There is an electric field applied between the cathode and anode, and by convention, the electric field points from a positive charge to a negative charge. At a certain point, the electric field can be described as the force per unit charge that a charge will feel. Thus, electric field exists at every point between the cathode and anode and can best be observed when the proteins are loaded. The proteins themselves will respond to the electric field in its surrounding area and migrate towards the anode, analogous to the way the moon responds to the Earth's gravitational pull. The polyacrylamide gel acts as a sieve, allowing smaller molecules to pass through it quicker than larger molecules.
Because Myosin is the smaller protein, they won the race for their team. The next day in gym class, everyone wanted Myosin on their team after seeing how they won the SDS-PAGE race. Their classmates learned that every protein is useful no matter their size.